Hello everyone, welcome to my YouTube channel. Today in the following videos we'll learn about data clustering, and it's a prerequisite for data analytics. It comes under the subject of statistical analysis, which is necessary for data analytics. So first let's know what's today's agenda. We'll study about association and dependence, causation and correlation, covariance, Simpson's paradox, and clustering techniques. So first let's go to association and dependence. So what is association and dependence? In statistics, dependence or association is any statistical relationship, whether causal or not. It's between two random variables, or we can say bivariate data. An association rule is a pattern that states when an event occurs, another event occurs with a certain particular probability. In data science, association rule mining is a popular and very well researched method for discovering interesting relationships between variables in large database. For example, let's take a customer who purchases a keyboard have a 60% likelihood of also purchasing mouse for their PC. Customer who purchases a mobile are very likely to purchase a case or a cover. Such information can be used as the basis for decisions about marketing activities such as promotional pricing or product placement. So now let's see what is causation. Causation indicates a relationship between two events. So when one event is affected, the other is also affected by it. I.e., that means when one event is changed, the other event is affected by it. In statistics, whether the value of one event or variable increases or decreases, the result other event is, say, event is also decreases or increases. It says causation. Theoretically, the difference between two types of relationships are easy to identify. An action or occurrence can cause another. For example, smoking causes an increase in the risk of developing lung cancer, or it can correlate it with another. For example, smoking is correlated with alcoholism, but it does not cause alcoholism directly. In practice, however, it remains difficult to clearly establish causation and effect compared with the establishing correlation. So here we see in the diagram, smoking causes lung cancer. Alcoholism indirectly causes smoking, which indirectly causes lung cancer. Alcoholism directly causes lung cancer. This is causation and correlation. So now we'll see what is correlation. So many times we have variables or parameters which have dependencies in between themselves, such as temperature versus ice cream. So here we can see, like when temperature increases, it's 17.2 degree, the ice cream rate sale is 408. When it's increased to 22.6, it's 445 sales. So when it's 18, it's again decreases to 421. So when we see temperature increases, the sale of the ice cream also increases. So to see how two variables relate with each other, we plot them together on a graph or a chart. So here the same thing, as I said, as temperature increases, the price also increases. Here the red line shows the orange line shows the sales, and the temperature shows the blue line. So now let's see what's correlation. When we have a various variable, correlation is an important factor to check the dependencies within themselves. Correlation analysis gives us an insight between mutual relationship among the variable. So what is covariance now? Covariance is a measure of how much two random variables vary together. It's similar to a variance, but when variance tells you how a single variable varies, covariance tells you how two variables vary together, as shown in the following graph. So we'll see formula of covariance. Covariance is summation of xi minus mean of x, yi minus mean of y. the whole divided by n minus 1, where x bar represents the mean of x and y bar represents the mean of y, and n is the total number of entities. So let's take an example. You want to get your eyes operated, but you're afraid because there is chance of failure in the particular procedure are very high. So you decide to use statistics to make your decision. So let's see how that goes. So this is basically Simpson's paradox. So we'll know what is Simpson's paradox. Here there is data available. There is Dr. A and Dr. B. Within period 1, Dr. Hay has operated has 63 successful operations out of 90. That is 70% success rate. And Dr. B has operated 10 operations and 9 of them were successful. So that is 90% success rate. So here we will prefer Dr. B as compared to Dr. A in period 1 because Dr. B has high level of success. But here we see again that there is 90 operations that Dr. A has done and Dr. B has done only 10 operations. So let's go to period 2. Here Dr. A has done 10 operations and out of which 4 are only successful. So there is a 40% success rate. In this, Dr. B has done 90 operations, but here 45 are successful. So there is a 50% chance of success here. So here we see again there is a paradox that is coming. So what we do is in the following. From the table we can see that during both period 1 and 2 are respectively, Dr. B had higher result success rate as compared to Dr. A, as I said, but the total shows that Dr. A has higher success rate. Clearly we have a conflict. So why such case comes? We'll see next. So why is it happening? That is we are not comparing the same things. During period 1 we compare 90 events to 10 events. Similarly during period 2 we compare 10 events to 90 events. That's why Simpson's paradox occurs. We are not comparing the same things. Now we'll see what is Simpson's paradox. Simpson's paradox occurs when n group of data show one particular trend, but this trend is reversed when the groups are combined together. Understanding and identifying this paradox is important for correctly interpreting the data. Let's look at its formula. So consider n groups of data such that I group has AI trials and which is AI is between 0 to AI, that is success. Similarly, consider an analogous group I has BI trials and BI is between 0 and BI successes. So then Simpson's paradox occurs if the following is true: if AI by capital AI is less than equal to BI by capital BI, and at least one of the inequalities is strict, meaning that there is not in the equality case. Thank you. That's all for today's video. Please comment if you have any doubt and please subscribe to my channel, and the next part of the video will be uploaded soon. Thank you.